In today's lab, we're going to do two calorimetry experiments. In the first one, we'll find the specific heat of steel, and in the second, we'll find the latent heat of fusion of water. So specific heat is a quantity that describes how much heat is necessary to change the temperature of a material. And if we're only doing temperature changes, then that's what we'll need. But if we're doing phase transitions, then we need something else. So phase transitions, that would be solid into liquid, liquid into gas, or the reverse of that. And if we're doing solid into liquid, we need the latent heat of fusion. So that's a quantity that describes how much heat is necessary for that process to transform a material from solid into liquid. And whenever there's any sort of heat exchange, then there's also going to be a resulting entropy change. And that change in entropy is going to be equal to the amount of heat that was exchanged divided by the Kelvin temperature that that process took place at. Now I'm going to show you how to do each one of these experiments. And first we'll go through the specific heat experiment, and then we'll do the latent heat of fusion experiment. So if you're only doing the latent heat experiment, you can skip ahead to that section. And if you're doing the specific heat experiment, then we're going to get started on that now. So before we get started, I can't stress enough, please read your instructions all the way through so you can plan what steps you're going to do at the right times. The timing and the order of things is important, so read them through and plan ahead what you're going to do at what time. Okay, so the first thing we need to do is put our pot of water on to boil. So I filled this up to about halfway, and I'll just turn the burner on and set this up so that it starts boiling. We don't want it to start boiling immediately, but depending on how fast your stove is, you may want to turn it up higher than what I just did. Now we need to measure the mass of the hex nut. So zero the spring balance and then hang the hex nut from there and record the mass. Then what you want to do is get a long piece of thread, so this is the heavy duty sewing thread from your lab kit, and tie it around the hex nut. Then get a wooden cooking spoon or something that you can wrap the string around. And I'm just going to wrap it around like this and then use this to suspend the nut in the water. When you do this, adjust the height so that it's hanging below the surface of the water, but it is not touching the bottom of the pot. Now I already prepared this bag with a twine handle on it, but you can follow your lab instructions and see how to make this. So we're going to use this to weigh some things. I'm going to put the cup in here and then weigh this on the spring balance. So just record the mass of that. And now we need to record the temperature of the hot steel, but it's not up to boiling temperature yet, so I'm just going to turn this up a bit and get it to boiling faster. This is a good time to mention that we'll need an extra glass of room temperature water, and you'll use that for equalizing the thermometer temperature. So just have that ready to go so that you're set for this next step. Okay, now our water is up to boiling, so I can check the temperature of the boiling water, which is also the temperature of the hot steel. So just put your thermometer in the water so that it's not touching the pot, just kind of suspended in the water there, and wait for it to come up to the highest temperature that it's going to. And it looks like mine came up to 100 degrees, which makes sense because that is boiling temperature for water. So now just take the thermometer out and stick it in your extra glass of room temperature water, and then record the hot temperature on your paper. Now what we need to do is put some water in our styrofoam cup, so fill it up about halfway with cold water. So what you want to do now is just wrap some towels around your cup, and this will add some extra insulation and keep it from losing heat to the environment or gaining heat from the environment. So just wrap that around there and check to see if your thermometer has come back down to room temperature. In my case, it looks like it hasn't quite, but we can go ahead and stick it in. It's pretty close. Meanwhile, keep the pot of water boiling. We need to keep that temperature hot right now while we get the cold stuff set up. So just wait for the thermometer to go down and equalize, and then record this as your cold temperature. Okay, so I think this has equalized now. It's at 16 degrees, and this was fridge water. It was from a dispenser in our fridge, so that's why it's extra cold. Okay, now what we need to do is get this all ready so that we can transfer the hot hex nut into the cup of water. So get your lid, and we're going to put this on here so that it's ready to cover up, and have another towel handy so you can put it over the top of everything. And then we're going to turn off the stove, transfer the hot hex nut in here, and then start stirring so that we can encourage rapid heat exchange. So when you transfer this, just kind of get it off of the spoon like this. So just lift it up, put it directly in your water, cover it up, and then start stirring and swirling and watch the temperature for it to go up to the maximum. As soon as it hits the maximum and stops rising, then record that as your final temperature. Right now we're up to 25 degrees. I don't know if it's going to go higher than that, but if it doesn't, then that will be my final temperature. Okay, I think that stopped rising. It's like 25 or maybe 24.5 degrees, so that will be my final temperature. Okay, now what we need to do is weigh everything. So we didn't weigh the water before, but we're going to weigh the cup, the water, the hex nut, and the bag, and then subtract off everything except for the water so that we get the mass of the water. So make sure to remove the lid for this. We're not going to use that. We don't want to weigh the lid. And then also shake off all the water from the thermometer if you can. So just get that shaken off. We don't want to lose that. Then just put the cup with the water and the hex nut into the bag, and we can record their mass. So just hang that from the spring balance and measure the mass. And that's it for this experiment. Then just complete your analysis and get the specific heat of steel and the changes in entropy. Now, if you're not going on to the next experiment, that's fine, but just go ahead and read your instructions and follow that to finish up the lab. Now, I'm going to clear up everything here and then we can get started on the second experiment. Alright, I'm ready to start the second experiment here, and this will be the latent heat of fusion experiment. So before we get started, I cannot stress enough, please read your instructions all the way through before you begin the experiment. You need to know what the steps are and what the order is and the timing so that you can plan everything and then execute them in order. Everything is time dependent, so you need to know what you're doing ahead of time and not be figuring it out as you go along. Okay, so first up I have this bag with a twine handle on it. And I've already prepared it ahead of time, but if you need to know how to make it, then read your lab instructions. There's detailed instructions and pictures on how to do that. But we're going to use this to weigh some different things for the experiment. The first thing we need to weigh is actually the bag itself. So just grab your spring balance and make sure that it's zeroed. And then just hang the bag from the spring balance hook and suspend it like that and record the mass of the bag. The next thing we need to weigh is the bag and the cup. So put the cup inside the bag and then again check the mass of that. So just record the mass of the bag and the cup together. Now we just need to add some water to our cup. So we're going to need about 100 grams or so of room temperature water. So you're just going to have to go back and forth between weighing it and then adding or subtracting water until you get about the right amount. So I'm going to fill it up about halfway to start with, and then I'll adjust it from there. So my bag and the cup together were about 15 grams, and it looks like the water plus the cup plus the bag are about 115 grams. So that's perfect. This gives us about 100 grams of water, which is what we'll want. So you'll want to record the mass of the cup and the bag and the water together, then subtract off the bag and the cup to get the mass of your water. Then we need to measure the temperature of our water. So just put your thermometer in the cup of water and let that come to an equilibrium. Room temperature is usually around 20 degrees, but I think my room is a little warm here, so we're getting about 23 degrees. I don't think it's falling anymore, so that will be my water temperature is around 23 degrees Celsius. Next we need to prepare the ice. And I'm just going to use some ice cubes from a tray here, but if you have them in your fridge, that's fine as well. So just get a second Ziploc bag here, and if you have ice cubes, then put your ice cube in the Ziploc bag. And then zipper it up, and we need to crush the ice. So we need to break it into some smaller chunks. And the way I'm going to do that, I'm just going to take this bag and whack it on the counter. So that broke it up some, but I'm going to grab a wooden spoon and break it up just a little bit more. Alright, that looks pretty good. Now we need to check the ice temperature. So I'm just going to open the bag and stick my thermometer inside. So just put the thermometer down in the bag and then wait until you see a little bit of water in the bag, so it should look like it's starting to melt. And at that point, then we know that it's at freezing temperature, which is what we want. So I'm not seeing too much water in mine right now, which means it's not up to the right temperature. It's still colder than freezing. Nope, there it is. Okay, I see some water now. This is at freezing temperature, and let's just check. Yep, it's at 0 degrees Celsius, so that's what we want. That is our ice temperature. Let me just take this out and then put it in a glass of room temperature water to bring it back up, so it's not going to affect our experiment. So just grab a spoon like you would use for eating, and you're going to scoop out some of the larger chunks of ice and put them in the bag that we're going to use for weighing. So pull out maybe 10 or so larger chunks. Doesn't have to be exactly 10, but just pull out some larger chunks so that they're all roughly equal sized, and if they're a little smaller, that's fine. But just do this quickly before they start melting more. If you need to, I suppose you could put them back in the freezer and let them refreeze a little bit, but you'll have to recheck the temperature. Okay, I'm going to stop with that, and let me weigh these real quick. So hang it on the spring balance and record the mass. Don't worry about subtracting the bag just yet. Do that later. So just record the mass of the bag and the ice. And let me just check the thermometer is back down to room temperature, so now I'm ready to start here. I know what the mass is. I'm going to dump this into my cup of water, put the thermometer in there, and start swirling it, and just watch. So you need to see exactly when the ice is all melted, and at that point record the final temperature. Okay, ice is all gone, and the final temperature is 16 degrees. So that's my final temperature. I had the initial temperature of the water, I had the temperature of the ice, which was 0 degrees, and then I have the final temperature, which is 16, and that's somewhere in the middle. And that's it for this experiment. So just complete the analysis, and you'll get your latent heat of fusion of water, as well as the changes in entropy. And as always, read your instructions carefully. They will have more information than what is shared in this video, and good luck on your experiment.